All right, so today we are going to talk about the second part of what we did on Tuesday, and that is more with vectors. So the first thing we're going to talk about is what does it mean for a vector to be in standard position. So for a vector to be in standard position, basically that just means that's when the initial point is at the origin. So what we can do here is we can talk about how to, the notation for component form. So the notation for component form would be, we call it vector v is equal to whatever the coordinates are of the endpoint. We're going to call it a comma b, but we're going to use those kind of funky looking brackets. All right, and then the magnitude of direction, we're going to talk about magnitude again. We are also going to introduce the idea of a direction angle. Last time we just talked about how we can sort of tell the direction based on the slope of the vector, but what we're going to do today is look at an actual way to do that. So to find magnitude, when our vector is in component form, guys, I'm going to apologize in advance. My dogs are going to be making noise in the background, so I just bear with me. We can use the Pythagorean theorem, but this time we know what the lengths of the sides are because they are just A and B. And this will make more sense when we take a look at this picture. So in this picture, all right, we've got the vector in component form, meaning it has its initial point at the origin. And the terminal point ends up being an ordered pair. And what we can do is we can look at that triangle that we form based on where our component, or based on where our endpoints are. And our horizontal length is just the x, is not a in this case. Our vertical length is just the y, and that is b in this case. So we have this triangle, and that's where we can just take the magnitude being a squared plus b squared, right? So it's a squared plus b squared equals c squared, which is our vector magnitude. All right, now the second thing we're going to talk about is this idea of a direction angle. So to find that, we need to think about trigonometry, back to our days with trig. So what we have here is a right triangle, and we want to know what this angle right here is. Thinking back to our trigonometry days, we have got this right triangle. I'm just going to draw it in the margin here. I want to know what this angle is. We're going to call it theta. This is my A, this is my B. What we know is the opposite side of angle theta, and we know the adjacent side for angle theta. Gosh, theta. I don't know where theta is coming from. So we can write a trig function that relates all of those together. And if you think back to your days of trig, SOHCAHTOA, TOA relates the opposite and adjacent side. So what I can do here is I can say that the tangent of theta will be the opposite side, which is B, over the adjacent side, which is A. Well, that gives me an expression for tangent of theta, but if I want to actually write theta, I have to undo tangent, and we do that by taking the inverse tangent of both sides, and this is all going back to your geometry days. So what we end up with is something that looks like this. To find theta, we have to do the inverse tangent of B over A. So that is going to tell us our direction angle theta. So theta is the inverse tangent of B divided by A. Okay, now that we know what it means to find the direction angle, let's go ahead and find it. We are not going to do the magnitude because we've already done that. So we're just going to find the direction angle for each of these. Okay, so first of all, the first thing I want to do with each of these is just kind of figure out which quadrant we're going to be in. So if I look at the point 7, 24, that's a positive x, positive y. So that's going to put me somewhere in quadrant 1. Okay, so my angle is going to be somewhere in there. All right, so to find it, we're going to take theta equals inverse tangent of, because we already have A and B, we can just plug those in. B is 24, A is 7. So we plug the inverse tangent of 24/7 into our calculator. And what you're going to get is 73.74 degrees. And let's just think about that for a minute and make sure that it makes sense. So if we have an angle in quadrant 1, does it make sense that the measure is going to be somewhere in the vicinity of 0 to 90 degrees? I mean, yeah, that's what we would expect to see. So this is our angle. And I'm just going to put kind of a note here. This is quadrant 1. All right, let's try another one. So this time, thinking about what quadrant we are in, we have a negative x and a negative y. So that's going to put us in quadrant 3. So our angle is rotating from here all the way to here. All right, so let's keep that in mind as we actually look for what theta is. So once again, we're going to use our equation, inverse tangent of b over a. That's -1 over -3, which, guys, I'm just going to rewrite that as positive 1/3, because when you have a negative divided by a negative, it's a positive. All right, so you type that into your calculator, and here's what we're going to get. Also, as a side note here, if you're doing this along with me and you're not getting the same angles that I am, you're probably not in the correct mode. So check your calculator. You need to be in degree mode because we're giving our answers as degrees. All right, so we're in degree mode, 18.43 degrees. However, when I think about the fact that I'm in quadrant 3, an angle measure of 18.43 doesn't really make a whole lot of sense. That's a very small angle. So looking at our picture, what that is giving us is this little piece of the angle right there. That's that 18.43. What we're not including is all of this. Okay, so it just gave us that little part of the angle between between 180 degrees and our vector. So in order to actually find what theta is, I'm going to have to take what I just found, which is 18.43, and I'm going to have to add 180 to it. And what that's going to give me is 198.43. That seems a little more reasonable. So that tells us the direction that our vector is going to be going in. All right, 2 more in this little section here. Okay, so we have vector v has a positive x and a negative y, so that's going to put us here in quadrant 4. Now, once again, there's a couple ways we can think about this angle, okay? We can think about it as we're going all the way around in a positive direction, or we're going backwards some amount in a negative direction. So there's 2 ways we could think about that, easily as we get our answers. So let's type it into our calculator. So theta equals the inverse tangent of b, which is -12, over a, which is 8. And that's going to give us, it's going to look a little strange here. Our calculator can only give us answers in certain formats when we are using inverse trig functions. So we get an angle that is negative. Now, it makes sense to think about the angle that we're finding as a negative angle. And it does make sense if we rotated -56 degrees that we would still be in quadrant 4. So this makes sense, but we want to give our answers as positive rotations. Right now it's a negative rotation. So what I'm going to do is I'm going to take my angle that I found and I'm going to add 360 degrees to it. Now, why am I adding 360 degrees? Right? I'm trying to figure out how much, basically you end up subtracting 360 and the angle that you found. So what you're saying is we rotated almost 360 degrees, but we stopped 56 degrees short of that. So what you end up getting here is 303.69 degrees, and that is our angle of rotation. So when it's in quadrant 4, we're going to add 360 to whatever we get when we type it into our calculator. Finally, and I bet you can predict where this one's going to be. So we are now looking at an angle with a negative x and a positive y. So we're here in quadrant 2. Now, when we think about that angle of rotation, it's going to be less than 180 degrees, right? So we should expect an angle that's less than 180, but it should also be positive. So we got to think about that as we get our answer here. All right, so let's use our formula. Theta equals tangent inverse of B, which is 6, over A, which is negative 11. And when you type that into your calculator, you're going to get negative 28.61 degrees. Now that's really weird, okay? So what that's really telling us, and I'm not explaining what it's actually doing on the calculator here. I'm trying to give you a visual of what's happening. So it's kind of looking at this backward rotation from 180 degrees. All right, so kind of similar to what we did in quadrant 4, because that's another place where our tangent values are negative. That's what we have here is a negative tangent value. So what we're going to do to find our angle, it doesn't make sense to subtract 360. It doesn't make sense to add 360. It doesn't make sense to subtract 180. Those are all going to give us either angles that are much bigger than we need, or they're going to be more negative. So the only thing that kind of makes sense here is we're going to take our angle that we found, which is 28.61, and we are going to add 180 degrees. And that's going to give us 151.39 degrees. That makes sense, right? That's an angle that would be in quadrant 2. All right, so let's summarize this. We have our 4 quadrants, and what we did with our theta that we're finding with our calculator each time is different depending on the quadrant. Let's just refresh here. Quadrant 1, what we typed in, that was our angle. Quadrant 2, we had to add 180 degrees. Quadrant 3, we also added 180 degrees. And then in quadrant 4, we added 360. So let's take just a minute to summarize those 4 things. All right, so I'm going to put it over in the little space we have here. So we have quadrant 1. To find theta, we're just going to type in the inverse tangent of B over A, and we don't need to do anything to it. That is our answer. All right, that's quadrant 1. Quadrant 2, to get theta, we're going to take whatever we get when we type in inverse tangent of B over A, and we're going to add 180 degrees to it. Now, I'm going to make a little bit of a shortcut here, and I'm going to say quadrant 2 and quadrant 3, because we did the same thing in both of those. And then in quadrant 4, to find theta, we're going to take the angle that we found, B over A, and we're going to add 360. Okay, so that is our little shortcuts that we're trying to remember as we're finding the different angles. All right, so we're going to look at the back, and we're going to talk a little bit about how do you get a vector that's not in component form to be in component form. So any vector where you have your endpoints known and not one of them are 0, 0, like we have with this vector right here. What we can do with that is, just like we've been doing with everything else, find the difference in the x's and the difference in the y's. And that's going to tell you what your component form. The other thing you can kind of think about is, how much do we move to the right or left, and how much do we move up or down to go from the initial point to the terminal point. And that's going to tell you what your final point would be if your initial point is at 0, 0. So we're just going to write a little formula here. So any vector where you have the initial point x1, y1 and terminal point x2, y2 can be written in, and I'm just going to call it vector v is equal to, and remember our component form uses those pointy brackets. We're just going to show that as x2 minus x1, comma, y2 minus y1. That's our formula. Whoops, pointy brackets. Okay, so that is how we're going to write our component form if we just know 2 points that are not at 0, 0. So we're just going to kind of jump right in here and go right to an example. We're going to do, let's do 10 and 12. Okay, we're going to do 10 and 12. So we'll start with 10. And notice what we're finding. We're finding all 3 things. We're finding component form, magnitude, and the direction angle. So we're going to start here at 10 and talk through those 3 things. So the first thing I need to do is find the component form. Well, I'm just going to take my formula that I wrote up above, this thing, and use that to help me find it. Okay, so to find the component form for AB, I'm going to do x2 minus x1, so -4 minus 9, comma, y2 minus y1, so -1 minus -3, and simplify. So -4 minus 9, that's -13. -1 minus -3, so we're going to add 3, that's 2. So we get a component form of -13, 2. That's telling us that our vector is going to start at 0, 0, and it's going to end at -13, 2. So let's start thinking about what quadrant that would be in, just so we have a plan. -13 is a -x, +2 is a +y, so we're going to be somewhere here in quadrant 2. Just going to make a little note of that for myself. Okay, next, let's find our magnitude. Magnitude is super easy when we already have component form. We're just going to find magnitude of AB by doing, and we can go back to what we did here a minute ago. It's just going to be a squared plus b squared and take the square root of that. So we're going to do the square root of a, -13, squared, plus b, which is 2, squared. And let's simplify. So that's going to be 169 plus 4. That should be 173. So our magnitude is the square root of 173. And that's what we found last time, was magnitude. All right. Last, we're going to find our direction angle. So to find the direction angle, we have to also remember that we are finding this in quadrant 2. So we go back to what we wrote a moment ago. Quadrant 2 means we're going to find theta by taking the inverse tangent of b over a and adding 180 to it. All right, so we're going to take the inverse tangent of b, which is 2, over a, which is -13, and then we're going to add 180 to whatever we get. Use your calculator here, okay? I'm not going to do this in steps with you. Plug it into your calculator. If you're using Desmos, there is a way to find, there is a way to change it into degrees. So just watch for that. If you're using the scientific calculator on Desmos, it's really easy to do that. So you could always use a scientific calculator, or you can just use your red calculators. You just might have to press the DRG button to change it to degrees. But when you do all of that, you're going to get 171.26 degrees. So we've got component form, magnitude, and direction. All right. Now let's do one where there's a graph given to us. Okay, so let's go to question 12. And I want to show you how we can just kind of visually figure out where the component form will be. All right, so we have our initial point here. Let me use a different color, make that a little bit easier to see. Initial point here, terminal point here. What I'm going to do is I'm going to I'm going to figure out what kind of movement do I have to do to get from the initial point to the terminal point. So what does my path look like? Horizontally and vertically, how much am I moving? So horizontally and vertically. Let's look at vertically. We have to go down 1, 2, 3. We move down 3. Vertically, we're moving horizontally, we're moving 1, 2, 3, 4, 5. So we're adding 5 to our horizontal component. What does that tell us? We're moving right 5. That's our X movement. Right and left is our X movement. And we're moving down 3. Up and down is our Y movement. That's telling us what our component form will be. +5 and -3. Now you could have also, figured out what the two ordered pairs are and done the formula from above. That would also be fine. But let's look at what that looks like. So if our initial point is at 0, 0, and our terminal point is at -3, we're going to have a vector that looks like this. Okay, so that is now the component form for vector C. All right, so our component form is 5, -3. Okay, let's find magnitude. Like I said, magnitude from the picture, we can figure it out. It's a vertical distance of 3 and a horizontal distance of 5. we can also get that from the component form, horizontal distance of 5, vertical distance of 3. And we're going to find the magnitude by just using our Pythagorean theorem. Again, that's on the other side of the paper. Square root of a squared plus b squared. So a is 5, b is negative 3, and then we get 25 plus 9 is 34. Now, I can see by my picture that my vector is in quadrant 4. Like, I can visually see that based on what I just did. I could have also figured that out just from the component form, right? Positive x, negative y, that is in quadrant 4. So if we go back and look at what we were supposed to do in quadrant 4, we're supposed to take our theta, whatever we get when we type it into the calculator, and add 360 degrees. So let's do that. So we're going to do theta is the inverse tangent of b, negative 3, over 5, which is our a, and then we're going to add 360 to that. Once again, I'm not going to go through those 2 steps there. I'm just going to type it all into my calculator in one big step, making sure if you do this in one step that you do close the parentheses around this fraction. Okay, that's going to be important when you're typing this in. And you should get, I think it's 329.03 degrees. All right. Okay, last thing I want to talk about here is how do we, on Tuesday, we talked about how to figure out if 2 vectors were equivalent, and it was quite a bit of work. We had to find the magnitude of both, and then we had to find the slope of both and compare them and make sure everything was the same. If we can put both vectors into component form, we can tell whether or not they're congruent or whether they're equivalent if they have the same component form. Because if they do, that means that both of them are starting at 0, 0, and then they're both ending at the same point. The only way that's going to happen is if they're the same length and they have the same angle. So let's just find the 2 component forms here, right? So AB, we're going to take x2 minus x1, so negative 7 minus negative 3. y2 minus y1, negative 2 minus 6. And you're going to get negative 7 plus 3 is 4, negative 4. And negative 2 minus 6 is negative 8. And then we'll do the same thing with CD. So we'll have x2 minus x1, so negative 1 minus 3. And then y2 minus y1, so negative 9 minus negative 1. And that is also negative 4, negative 8. So because they have the exact same component form, these are going to be equivalent. All right. So it's a much quicker way, and you could probably do this even faster than what I just did, but it's much faster than having to find the magnitude and the slope to determine whether or not the 2 vectors are congruent. Okay, what I would like you to do first, and then you can take your break, is I want you to go up and try question 11. I'm going to actually give you the answers to it right now. And then as you're working, if you don't get them, the sub will have the answers as a key. Ask her to look at it. She can show it to you. And you can see my work and see how I got the answers that I'm writing here. And then hopefully that will help you figure out where your mistakes are if there's anything that you don't get right. So I want you to try question 11. That's it. Just question 11. You have 3 things to find: component form, magnitude, and direction angle. And this is getting you prepared to finish up that cut and paste activity. So here's the plan. So we're going to do question 11. Then you're going to take your break. Once you get back from break, there's 2 things that you need to get done. The first is the sub is going to give you a foldable. Now, she has a completed version of it on my desk of what it should look like once it's in your notebook. My assignment for you is to try to do the 2 problems at the bottom. So there's There's one where you find the component form and one where you find magnitude. So try the problems in the foldable. There's 2 of them, okay? And then you're going to finish the cut and paste activity. In that cut and paste activity, you're now going to be able to figure out what the component form and the direction angle are. So in your partnership that you had from last time, work through finding all of the component forms for your vectors and finding all of the direction angles. If you were out on Tuesday, the sub does have on the desk your makeup work. So make sure you grab that, because that'll be helpful for you to kind of do what we're doing right now. Also, there is a video posted in our calendar for Tuesday's lesson. So if you were out on Tuesday, after you come back from break, you can do the foldable, but then at that point, maybe go and do, watch that, it's like 15-minute video from last time and see if you can fill in the notes that the sub has for you. All right, guys, have a great weekend. I will see you all next week on Tuesday. Let me know if you have any questions. You can send me an email or leave a note with the sub. I will see you next week.